Hello Year 7 and welcome to the second lesson in the Chapter 12 Constructions and 3D Shapes topic. In this lesson we're going to look at constructing triangles, so we're going to need a protractor, a ruler, a pen and a pencil, and this is going to cover page 220 to 221. Okay. So to begin with, what we're going to look at is just a bit of terminology. So before we get into all the key aspects of constructing triangles I need to talk to you a little bit about how we detail our information in a written way rather than a diagrammatic way. So for this triangle here, we would call this triangle DEF. Okay, this is just in alphabetical order, so we use the vertices of our triangle and we just do it in alphabetical order, so D, E, F. Okay. Nice and straightforward. Then, secondly, we need to talk about how we detail the lengths. Okay, so all these sides have got different labels. So this side here would be DF, this side here would be EF, and this side here is DE. Okay, so we would write DE is equal to 3 centimetres. So that just means go from point D to point E, and how long is that? So 3 centimetres. Okay. The next bit is we're going to talk about some angles. Okay, so angles is a little bit different, and I'm going to give you 3 different ways of writing angles. The first way is going to be how it's detailed in the book, and the second 2 ways are going to be things that you will use later on in school. So in the book it is written as angle D to mean this angle here. So the angle on the vertex D is 25 degrees. Later on in school you will have to use things like angle FDE. Okay, so it just goes from vertex F to D to E, and that would be that 25 degrees there. Or, if we're feeling a little bit lazier, we could say EDF and stick a little hat, little arrow, little hat on the D. Okay? And we know that is equal to 25 degrees. So here, the only thing that matters with these 2 pieces of terminology is what the middle letter is. Okay? Notice that I've swapped around the F and the E in both of these, but they still mean the exact same thing. This little hat just means angle, so I've got angle D in all of these. Okay, so EDF with a hat on the D means I go from E to D to F, and what angle is made. Okay, so similarly, angle E, which is what you would see in the book, we could write as angle FED, or we could do DEF with a hat on the E, and we know that is 45 degrees. Okay, so now what we're going to do, so once we've got the terminology out of the way, which will be really useful for question 3, we're going to now look at actually constructing some of our triangles. Okay, so the first example I'm going to go through is called an ASA triangle, and that just means I need an angle, an included side, I'll get to what that means in a moment, and another angle. Okay, an included side is just a side in between 2 known angles. Okay, so here I can see that 3 centimetres is my included side because it's in between the 25 degrees and the 45 degrees. Okay, so now let's get on with actually constructing that triangle. Oh no, wait, before I do that, the reason we need an included side I'll get to a bit later on, but if I had this length here, I wouldn't be able to construct this triangle accurately. Say I didn't have that one, but I only had this one. I wouldn't be able to do it straight away. I'd need to do a little bit more work first, and I'll get to that at the end of this video looking at question 4. Okay, so we will get on with constructing this one now. So the first thing that we're going to do is we need our ruler and our pencil, and we're also going to use our protractor. So we need to draw our baseline at 3 centimetres. So I'm going to just draw a 3 centimetre line just there, And it's really good practice to label as we're going along, so I know that's 3 centimetres. that is point E, that is point D. Okay, so first bit, nice and straightforward. Next bit, we're going to use our protractor. So I'm going to place my protractor on the D part of my line because I'm going to measure this 25 degrees first. So I'm going to place my middle of my protractor on the end of the line, baseline of my protractor along the 3 centimetre line, and now I'm going to measure 25 degrees using the inside scale because I'm going up here. I'm measuring that angle going up there. So I'm going to get up to 25, make a small mark. I'm going to move my protractor out of the way, get my ruler, and join up the end of the line with that mark I've just made. Okay. Now, I've made this a lot longer than it needs to be, and the reason that is because I don't actually know what this length here is. I haven't been told that distance, so I'm going to make it a lot longer than it should be, so I'm safe. Okay. And then I'm also going to mark in my 25 degrees. Now my last other bit is to do my 45 degree angle, so exactly the same but on the E now. So I'm going to place the middle of my protractor on that point, get my baseline all nice and level, and then I'm going to measure 45 degrees using the outside scale this time because I'm measuring this angle going up here, so I want that 45 degrees. So measure a small mark there, move this out of the way, and get my ruler. Now with this one, I don't actually want to draw a massive line to create a cross. I just want to draw enough line so it joins up to the triangle, so I'm finished. 45 degrees, just need to label this bit F. Okay, so now we're done, completely finished. We're not going to rub out this line or this dot because like in the previous video, that is our working out, so we don't want to rub that out at all. Okay, right. If you would like to pause the video there, you're more than welcome to. If you would like to practice these questions, it would be question 1 and question 3A. It's also question 4, but I'm going to get to question 4 towards the end of the video. But question 1 and question 3A, and I think that should take you about 2 minutes per construction, so that's around about 8 minutes, so 8 to 10 minutes for that section there. Okay. I'm going to now have a go at the second example, which is a slightly different construction. So this example is called an SAS triangle. Okay, and for that one, I need a side, an included angle, and another side. Okay. So again, that included angle, the included bit, just means in between the 2 known side lengths. So the first thing I'm going to do is I'm going to draw a very quick sketch of what this triangle looks like in the book. It's always a good habit to draw a sketch just because it's always nice to know what your triangle should end up looking like. So that's 55 degrees. That's 3.5 centimetres, and that's 2.5. Okay, and we're told that that is P, that is Q, and that is R. Okay, so again, we're going to detail our information in a written form rather than diagrammatic as well. It's also in the book, just so we're happy with that and we can actually tackle question 3 quite confidently. So here, this would be known as triangle PQR. We would have length PQ is equal to 3.5 centimetres. PR is 2.5 centimetres, and we would say angle P, which is the same as we could say angle QPR, or it's the same as just writing RPQ with a hat on the P, and we know that's 55 degrees. Again, just to confirm, this is the form you will see in this book at the moment, but later on in school, that is what you would need to get used to. Okay, so I'm just giving you a heads up now. If you're happy with that, then that's great, but just to let you know that later on in school, these are the forms that you're going to use, mainly this one. Okay, So now let's get on with constructing that triangle there. So exactly like the first one, we'll draw ourselves a baseline, so of 3.5 centimetres. Okay, and we're going to label that. So P was on this end, this is a Q, and this is 3.5 centimetres. And now we're going to get our protractor, place it at the left hand side, so where the P is, because that's where the angle is. Place that there. And now I want to measure 55 degrees. So again, I'm going to be using my inside scale, because I'm starting at 0 and I'm measuring this angle coming up here. 55 takes me to there. So all very, very similar to the first bit, but now this is where it's going to get slightly different. So for this one, I don't actually want to draw a super long line. All I want to do is I actually want to draw that 2.5 centimetre line. So I'm going to start at 0, go up to 2.5, but I'm making sure my ruler goes through that mark I made when using my protractor. So just a 2.5 centimetre line. And then it's really good practice if we label this 55 degrees, like it was in the book, in the example, then 2.5 centimetres. And then the last thing I need to do is actually make it into a triangle by joining those two up there. I'm just going to label that one. Okay, so again, we're not going to rub out that little mark there because that shows our working, it shows that we've used our protractor correctly and we've accurately constructed our triangle. So if you'd like to pause the video there, and you can have a go at questions 2 and 3b. So all of question 2 and 3b. And again, I think that should take you about 2 minutes per construction. So that's another maybe 8 minutes, 8 to 10 minutes as well. Okay. Right, so like I said, I'm going to have a go at question 4 now, because actually the information that we're given doesn't necessarily indicate an SAS triangle or an ASA triangle. So I'm going to go through that one now. Okay, so this is question 4A on page 221. Okay. So again, I'm just going to do a very quick sketch of what this triangle looks like in the book. It's always useful to have a little sketch so we know what we're aiming for. And then that's 40. I've got this up here. Okay. And we've got that as 8 centimetres. Okay, so now we know the triangles that we're able to construct at the moment are ASA triangles or SAS triangles. So we either need 2 angles and an included side, or 2 sides and an included angle. Here we have got 2 angles, but our side isn't an included side. We don't have 2 sides, so it can't be this one just yet. So we need to look at how we're going to make it into an SAS triangle. An ASA triangle. So we know that there are 180 degrees in a triangle. Okay, so we know there are 180 degrees. If we add up all the angles of a triangle, we should get 180 degrees. So if I label this angle here as X, I know that X degrees plus 80 degrees plus 40 degrees must give me 180 degrees. Okay, so then that tells me I can then simplify my calculation to give me this. So 80 plus 40 is 120, so X plus 120 must equal 180. So then I know that X must be 60 degrees. Okay, so if I know this angle, and I've got this side, and I know this angle, I have now got 2 angles and an included side. So that way I can now accurately construct that triangle there. So if we just have a go at doing that, we're going to draw ourselves 8 centimetre line. So nice and quickly, 8 centimetres, and we're going to label it. Get our protractor, measure our 60 degrees on the left, because that is what X was. 60 degrees, it's up here. I don't know how long that is. I'm not given that information, so I'm just going to draw a nice long line to make sure I am safe with it. I'm going to label my angle, and then I'm going to get my protractor again on the other side this time, and I'm going to do 40 degrees using the outside scale. It's not going to be a massive line this time, it's just going to join it up, so I've actually got a triangle. I'm going to measure that as 40 degrees, and then I can just check, because the information I was given is I was told that top angle was 80. I haven't measured that, so if I quickly check now, it should be 80 degrees, and as we can see, I'm at 80 degrees just there. Okay, so I know that is 80. And then I'm done. So 4B and 4C is a similar style to what we've just done there. 4B is an isosceles triangle, so you need to think about what that means for those bottom two angles, and hopefully you can work that out. And 4C is very similar to what we've just done here. Okay, so you can have a go at 4B and 4C. That may take you a couple of minutes per question, so that's maybe another 5-6 minutes. And if you've done all of that and you'd like a bit of a challenge, have a go at the problem solving questions at the bottom. If you found any of this a little bit tricky, or if you get stuck with any of this, please email your class teacher and let them know that you need a little bit of help. But otherwise, good luck with all of the other questions, and well done for today.